So far, all the integrals that we've done so far have had the letter C attached to the answer. This is a generic solution. Now we're going to figure out how to solve for C. To do that, we first need an initial condition. For example, if we're given the integral 3x squared minus 1 dx, let's first find the integral. We're just going to reverse the power rule. So we're now going to add 1 to the power and then divide by that new power for each term. So our function will look like x cubed minus x plus some constant that we don't know what it's going to be. So they have to give us an initial condition. We figured out the general solution, and now they're going to give us a coordinate or a point. They're saying when x is 2, it will equal 4. So the point is 2, 4. So what we're going to do is we're going to equal the equation to 4, or the function 4, and plug in 2 for the x's, and then you can solve for C. So again, we substituted the 4 in, and the 2 for the x's, and then you can solve for C. You can see C equals -2, so now we can rewrite our final answer, not with the C, but you can now plug in the constant -2. This again is called a particular solution. Let's try another example. So we want to find the particular solution. We're going to integrate the function. When I go to integrate, I'm going to write x in the numerator. And then we're going to integrate. So we're going to add 1 to the power. That will make it x to the -1. And then we're going to divide by that power. So we will have negative x to the -1. So I'm going to then write x in positive exponents plus c. So this is what the function will equal. But this is just a generalized solution. Let's now find the particular solution. When x is 1, the y value is 0, or the function equals 0. So plug in 0 for the f of x, plug in 1 for the x, and solve for c. We can solve for c by adding 1 to the other side, and we see c is 1. So the particular solution for the function will be -1 over x plus the 1. Try one here. Find the particular solution. First, integrate the function by adding 1 to the power and then dividing by that new power, and then solve for c. Remember, it'll be 4 equals, and then you'll plug 1 in for the x's. Choose which would be your answer choice. 1, 2, 3, or 4. We can actually do this twice. If they give us the second derivative, let's try and find the particular solution of the original function. So first let's integrate x squared. So I've added 1 to the power, divided by that new power, and added the constant. This is now the first derivative. So I'm going to plug in x is 0 and the y or the function equals 6. So 6 equals 1/3 times 0 cubed plus c. This is an easy one. This whole term will drop out. C equals c, 6. So my first derivative is now 1/3 x cubed plus 6. Again, this is the first derivative, so we're going to integrate again and then use the other initial condition that they gave us. So adding 1 to the power gives me a 4. Now I already have a third out there, and I need to divide by my newest power. So now I have 1/12 x to the 4th plus 6x plus a constant. So I'm going to equal this to 3 and plug 0 in for these x's, which again 0 is easy because that's going to drop these terms, and we'll see c equals 3. So my final answer, or my final function, will be 1/12 x to the 4th plus 6x plus 3. Remember, you can always check your solutions by now finding the derivative of our answer. Now we can apply what we've learned to a word problem. Here, a ball is thrown upward at an initial velocity of 64 feet per second from an initial height of 80 feet. Let's see what this looks like. So you can see here, I'm standing on a height of 80 feet. I'm going to throw the ball upward and then downward. Notice that the acceleration is given. If you remember, the acceleration function is actually the same as the second derivative of the position function. And they gave it to us as 32 feet per second. So now let's work backwards. We can integrate the acceleration function, or the second derivative position function, in order to figure out the velocity function. So I'm just going to add my x. Don't forget plus c. Now this is my velocity function, or the first derivative. We can solve for c because we know that the initial velocity is 64. So at 0, time is 0, the initial velocity would be 64. So if I plug 0 here and I equal it to 64, I'm going to get my c value to be 64. We're now going to integrate again. Integrating the first derivative will give us our regular position function. So I'm going to integrate this last answer. I'm going to add 1 to my power. That'll become squared. Divide by that new power. Again, add 1 to make it 64x plus my constant. Now, the initial height or position is 80 feet. So when time is 0, when x is 0, it's going to equal 80. I probably should have used t's here instead of x's, just so you know. There we go. And so again, plugging 0 in for those t's or x's, I'll get c is 80. So my final position function will be negative 16t squared plus 64t plus 80. That's answer A. Answer B, when will this hit the ground? Or in other words, when will this equal 0? The position will be 0. So hopefully I can factor this instead of doing quadratic formula, and hopefully I can take a negative 16 out, which I can. That will leave me with t squared minus 4t minus 5. I can then factor this to t minus 5t plus 1, which will give me time values of negative 1 and 5, and negative 1 wouldn't make sense, so 5 seconds will be my answer.